Welcome to wasmCloud Wednesday for October the 27th. As usual, we're going to get started with the demo. Brooks, we'll turn it over to you.
Excuse me.
So the wasmCloud team is all together today, or some of the wasmCloud team is all together today in Washington, D.C. working on roadmap issues. So we're just hanging out.
Yeah, we're going to share my screen. Should be able to see a nice little YAML here. I'll put it a nice little demo or the diagram first, actually. So this is kind of a half demo, half just showing off what some of the work that I've put in on our build and release pipelines lately. What we previously had was like we had three different GitHub actions with various degrees of building artifacts for testing and for releasing, and we were not only like copying and pasting things in places, but we were also doing it kind of inefficiently. So I've refactored the wasmCloud host action to use matrices more efficiently. So we have our build and test matrix, which tests a variety of Elixir and OTP version combinations. And then after that passes, our build and test pass, we're now using a matrix to build our release tarballs for Windows, Mac, and Ubuntu, and for Linux. We're also releasing the Docker image as a separate step, and then once all of that is successful, we create a GitHub release. What you're looking at here is just the it's the manual release for this. So we can manually kick off building the application tarballs at any time. That doesn't release a new version of the Docker image. It's not going to create a new GitHub release or anything like that. So to show you what this looks like, previously we had a workflow to build host core, a workflow to build wasmCloud host, and we had a manual build action. That manual action for creating tarballs for testing, we kind of consolidated into, into the wasmCloud host action here. If we take a look at that, you can see the job build strategy that we've got the, here, let me do this real quick. That'll give you a better view. We have the build strategy for different Elixir and OTP versions. That kind of just runs our, great. Oh, nice. That just kind of runs through our build and test process. If we run down here a little bit, we have the release Docker action. That only runs when we run a tag push. It's not when we run manually. But notably, something that's added here is the platforms section here. So before we were just building and releasing for a Docker file for AMD 64 architectures or like x86, but with the Apple Silicon, like M1 chips, silicon, it's like an ice cream cone. The Apple Silicon chips and other various ARM devices, we have the ARM Docker image now. So the next release that we make should be more accessible to them. And then lastly, just to give you an idea of what this looks like to build the artifacts, the matrix is actually fairly simple. A lot of this previously was just copy paste between the different targets, but we have our three different OSs that we target with pinned versions on GitHub action runners. So Ubuntu, Windows, and Mac OS. And then this action just runs on the build matrix, or it runs on whatever operating system we are using for that. Most of this is pretty generalized. You don't have to change much per operating system. There are a couple places that, like, setting up Erlang and Elixir is different for Ubuntu than it is for Mac, and that's usually just a limitation of whatever, like this ERLF setup beam only works on Ubuntu and on Windows. It doesn't work on Mac, so we use the brew version here for Mac. But what this ends up making is a much more concise flow for releasing our application, and really enables us to do things like releasing only host core should be fairly simple to follow the same process that we're using here. So yeah, that's pretty much what I had going on. Anybody have any questions or want to see a little bit more about this flow?
Yeah, Brooks, do you have like the next steps or improvements kind of laid out anywhere for this, in a repo somewhere?
I have there's a couple different issues in the OTP repo. So one that Taylor put up is building host core only for the Docker image. I think we should release tarballs with just the host core too. It's going to be, without the UI. It'll be more like minimal, something you'd run on an edge device because you don't need the dashboard and all of its dependencies included there. And then this npm dependencies for wasmCloud host is more of it's another issue for just kind of trimming down what we use in the Phoenix dashboard anyways.
Okay, great. And apologies to everyone. We had some pretty insanely hot chicken for lunch. So there's still some lingering after effects on our spicy eating contest here. A couple of us are in the weeds. Well, thank you, Brooks, very much. Jennifer, you've got a great demo, or you have a demo of some questions you wanted to pull up and take us through. You want to go and share your screen?
Yeah.
Super.
Actually, share screen. One. And share. You guys should be able to see a couple of VS Code's windows open as well as the terminal down the bottom. Is that correct?
Yes, that's correct.
Okay. So on the right-hand side here, I have
the text is a little small. So it's like we're like a screen for ants.
Yeah, I'm on dual monitors. Well, I'm on a large monitor, which is kind of why I wanted to have windows open. Is that okay? Or do you want me to switch over? I think you're going to be sure again.
Are you on Linux?
I'm on a Linux computer, but I wanted to use a large monitor because I wanted the windows side by side.
If you could maybe just like command plus or like control plus it, just make the text a little bit bigger, that would probably help.
Yeah, they should be able to stay side by side.
Yeah.
After you change the font size.
Is that cool?
Maybe just a little more. We've got it projected on a wall.
Yeah.
Quoting Taylor, you zoom in until it feels ridiculous,
and then go 2 more steps up.
I lost the effect of the larger monitor now, having everything oversized. So on the right-hand side here, I'll just blow this up now, actually. This is a simple test that is written in Go that pretty much does what the operator does, which is to load the applied YAML onto the wire. So we had an opinion of doing this through JSON, and when looking at the Lattice controller, the YAML seems to be a lot better. So I just converted that and YAML marshaled it, and that will go on the wire. Also, I did choose k8s.io YAML because that serializes a lot better than this guy here, because I guess the recursive descent processor doesn't actually work well for the data structure that we've chosen here. I have a NAT server running in the background here. It's not using Jetstream, so I will actually end up starting the test here to listen. So right now, this has a link started, it goes through there, gets and listens on the same topic that we're publishing to, which is just, well, somewhere down here, but actually down here. Has a small timeout, so I don't wonder what's going on. Then I get that and I serialize it into a map because that's the way it gets read, and then that gets called into an aspect. This is pretty much copy paste code from what Kevin had before, and I've kind of hacked it because I don't necessarily understand all the parts, and also the fact that I haven't completely figured out how to configure VS Code to work nicely with Elixir yet. Things are a bit rough on me, so bear with me there. So this is just showing the reconciler working. I've changed the weights here to pretty much use the same that we had before, or that actually triggers this and as normal. So it uses 50/50 and US West and East here, and that maps down here to the zones. So what I will do is start the test. which will, actually, no, and I'll probably put something. So I'm starting using just a tag. So this is me learning Elixir on the fly here actually, but that tag actually must exist here. So I'm going to do that. That will actually be listening. You'll see it actually listen there down the bottom, and then I'll actually run the test here within 10 seconds. And so yeah, the message actually came through, and it got, well, this is for, I guess, sanity check, just to dump it out as an inspect, which is just coming out of this part here. So it is coming through the wire, it's listening on the right topic, and then it reconciles, so to speak. So the questions are, I'm not necessarily sure how the apply event actually works, and I see that the reconciler actually has opinions on things like if there is not enough enough actors, or if there aren't enough actors on a certain zone, it will actually throw up, for example. And I guess I just don't know how the whole flow is supposed to work. So for example, if I change this to 80, I will actually run it. Probably nothing was listening here, so let me put it into listen again and run it through. And this test will actually fail with the error based on the reconciler. Yeah, or it didn't. Yeah. So this is, well, I thought it actually failed, but I guess in this case it doesn't actually fail because it did pick up 80 properly. Yeah, that's kind of the extent of what I've actually hooked up. I haven't hooked it up all the way to OTP, and I'm also not sending messages back yet. And I was really wondering whether that's kind of the intention of what we want in terms of the flow of what needs to happen between the operator and the Lattice controller. And then going from there into, I guess, I haven't looked at the observability code yet. And I guess that needs to eventually talk out to OTP. So yeah, I've put some pieces together. I don't necessarily know that they're in the right order. It just uses the fact that it looks like this is a layout that is kind of gonna work. But that's just me guessing at what I'm trying to make sense of, I suppose.
So can you hear me through the mic? Okay.
Yeah, I can hear you.
Okay. This is a great demo. I think part of the stuff that might be confusing right now is that the reconciler just emits recommendations to be taken, and there's no code written yet that actually takes those actions. So the reconciler is designed as a pure functional model where it looks at the state of a lattice and the application plan or the application spec, and then gives you a list of things of gaps that need to be closed. So it might tell you that you need to start one more actor or terminate an actor or you know, do something like put a link definition or something else. But there's no code written yet that actually acts on the recommendations that the reconciler makes. The other thing is that we've moved the Lattice observation code, so the observed directory in the Lattice controller, that's actually now part of a repository called Lattice Observer. And so the goal is to make it so that the observation of a lattice is a reusable Elixir library that can be used by both the Lattice controller and the dashboard for the wasmCloud OTP runtime. So what you've got here is pretty close to like a hard-coded version of what we're actually going to end up building. So this is great, especially, you know, like the piece that we haven't coded yet is how do you get the app spec YAML file into the Lattice controller. And so that looks like that's what you kind of hard-coded in your test there. And so we'll eventually have all that stuff fleshed out. But yeah, my apologies for us not having the code there. It's just, you know, we've been working on other priorities, so the Lattice controller stuff hasn't been moved as forward as I'd like it to be.
Yeah, that's fine. So I guess
Pretty impressive given how little of it we've actually coded.
yeah, thank you. So is the reconciler, so I guess how does apply event actually come into play here? Is the intent that you get the recommendation from the reconciler and then you call apply event to?
So apply event produces a new version of the state, which is the observed lattice. And so the workflow, once we code it, is we receive events from the wasmbus.evt.whatever NATS topic and apply all of those as they come in to the observed lattice state. And then at some timed interval, we will then ask the reconciler to look at the observed state of the lattice with regard to a given app spec. And the reconciler then gives you a list of actions that need to take place in order to bring the state of the lattice to its desired state versus its current state. So if the reconciler has no recommendations, then you can assume that the lattice has or is in your desired state in order to satisfy that particular app spec. So what's not coded yet is the control loop built into the Lattice controller that applies events, puts the state through the reconciler, and then converts the reconciler recommendations into commands issued to the Lattice control interface, and so on. So I'm hoping that we'll have some more scaffolding in place so that you'll have some more to work on.
Okay. So then how do we, so I guess with the operator, with the Kubernetes operator, if you're, I mean, it kind of sounds, well, I mean, the control loop idea, right? So like the operator itself is designed as a control loop. Kubernetes operator, sorry. So then there are kind of two things running, controllers running at the same time.
Yeah.
I don't necessarily grok that all the way of how that's supposed to work, I suppose.
Yeah, so most of the time when people build a Kubernetes operator, it's that operator that does all the work. In this specific scenario, what we wanted was to have the ability to monitor deployed applications in a Lattice and manage those either from a Kubernetes operator or without a Kubernetes operator. And so what the situation we end up in is the Kubernetes operator is really more like a proxy for the Lattice controller. And so when you push the YAML app spec to the Kubernetes operator, it should then just push that on whatever API endpoint the Lattice controller has exposed. And then the Lattice controller is then responsible for managing running the control loop on it. So the control loop of the Kubernetes operator should at a high level be pushing the app spec to the Lattice controller and then receiving second order or higher level events from the Lattice controller.
So I guess then if, for example, we had a situation where the Lattice controller makes recommendations which are realistically different from what the app spec asks for. Like the error that I was actually trying to trigger is when you don't have enough actors in one zone, and I guess I didn't actually trigger it probably because I didn't drop the numbers properly. But when that happens, what is the status that we want to return back to Kubernetes? Because now the app spec is going to be different from what's actually on, I guess what's declared is going to be different from what is reality. How do we want to reflect that back?
Yeah, so I'm not really sure of all the details, but generally what we're going to want to be able to do, so the Lattice controller will also allow you to query the current state of the observed Lattice. And so the Lattice controller is responsible for mutating the state of the Lattice so that it makes the app spec happen. And so the Kubernetes operator is basically just responsible for getting that app spec into the hands of the Lattice controller, and then sitting back and letting the Lattice controller do all of the work. And the Kubernetes operator then reports on the state changes. So if there's a gap between the current state of the Lattice and the desired state, then you'll be able to query that through the Lattice controller's API, and you'll be able to get that information. You'll be able to bubble that information out through the Kubernetes controller, but that API doesn't yet exist. So there's, like I said, there's not really that much you have to go on. So I'm kind of impressed that you've got a demo that goes this far.
Thank you. Yeah. Okay. So I guess what can I try next, I suppose, because I think I have more information. I think I would like to hook it up all the way to OTP and see what actually happens, but that would just be me like grappling through a bunch of stuff.
I would probably not spend effort hooking things up to OTP because, like I said, we have work happening in the Lattice Observer repo that is building an OTP supervision hierarchy for observation. And we're then going to, once that's up and running, we're going to go back into the Lattice controller and build another OTP supervision hierarchy that incorporates both of those. So I don't, while it feels bad to tell you to not do anything, I think at least for the short term, it's probably best to wait a bit because
okay.
I don't want you to have to, rig everything up to OTP on your own, and then you suddenly see a pull request come through that redid all of the work that you did.
Right. Yeah. Understood.
Janitha, this is awesome work. Great job on this. Kevin, how do we coordinate, the next steps here between the Lattice controller and this operator?
Basically, like I said, the suggestion is going to have to be for people to hold off on contributions to the Lattice controller and the Lattice Observer, at least for a very short period of time until we can get the changes that we're making to them pushed out. And then after that point, when all the scaffolding is in place, we should be able to take contributions. But right now, it's just it's too much in limbo, and we just haven't had the time to move it forward the way I wanted to.
Okay.
Janitha, is this blocking you for something, or did you just think of it as an interesting project?
Just something interesting to do while I have some spare time, and the spare time might be running short pretty soon. But for me, it was just, well, I mean, since I kind of kicked off the controller or set off the direction, at least I wanted to see how far I can push it to see the whole thing working together. But I don't have a business use case, at least at this time.
Okay, super. All right, well, we are doing, roadmap planning now this week. So let us get through a little bit of a prioritization on our side, but I definitely feel that, you're kind of blocked on this at the moment. So that feels like this kind of escalates the priority a little bit, but let's see what we can do to try to get you moving again. So this is great work. And I think that, my personal belief is that this is pretty important to go and start where our users are today in the Kubernetes ecosystem so that we can help be the bridge to the future. So this is, to me, I think this is pretty valuable effort here. What else? Open calls here. I don't think we have anything we want to present on Zendesk, Steve, or anything roadmap wise from planning, just given what we're doing this week is just, trying to plan out the next couple months of work here.
Yeah, we'll definitely make some posts on the Slack next week.
Okay, all right. So we'll take the output of this week and we'll do some posts next week and pick up and go from there. Is there anything else that anyone would like to demo today? Okay. Okay, I think we'll go ahead and stop here today. I really appreciate everybody's time, and Jordan, a huge call out and thanks to you. The the wasmCloud Wednesday videos look great. I love all the new headers and stuff you put in there, and it sure is great to get that stuff out. And I noticed you've even started tweeting out contents of the meetings and calls to action and things like that. So thank you very much. And I think we shared on Slack the the output of the survey around what languages to focus on next. I think we do have some business use cases coming up around C++. So the business users may kind of push that to the top of the pile if somebody is blocked on going into production there. But we'll give some feedback out over the next few days as we get to roadmap together here. Okay. Thank you very much, everyone. I hope everyone has a great day. Bye.